Welcome friends to my YouTube channel. On my last lecture, I have discussed the various derivations related to elastic constants and how they come. Okay. Now, in today's lecture, I shall going to discuss few numerical problems, or you can say few problems. Okay. So, the first problem is today is that we know that value of Poisson's ratio, that is sigma, lies between -1 to +half. How we can verify it? Okay, value of Poisson's ratio lies between -1 to +half. So how we can verify it? We know the relation y equals to 3k into 1 minus 2 sigma. Okay, so from which we can write y by k is equals to 3 into 1 minus 2 sigma. Now you all know that Young modulus and Bach modulus both are positive quantities. That means right hand side is also positive. So since y, k both are positive, the right hand side is also positive. That means we can write this. So this, that means we can write this. Okay, from this relation we can write this. Now again we know another relation, that is y, this is simply 2 eta into 1 plus sigma. So from which one can write y by eta is equals to 2 into 1 plus sigma. Now again Young modulus and rigidity modulus both are positive. So since eta both are positive, we can write this. Okay, that means from this relation we can write this. So previously what we found? Previously we found half greater than sigma, and here we found sigma greater than -1. So combining what we can write, half greater than sigma greater than -1. Okay, so this relation clearly indicates that the value of sigma lies between -1 to +half. Okay, so this is a short question. Okay, and very important. So the value of sigma lies between -1 to +half. Okay. Now the second numerical is that for a homogeneous elastic body, we have to show that dV by V is equals to dl by L into 1 minus 2 sigma, where dl by L is the longitudinal strain. Okay, dl by L is the longitudinal strain. So just make a closed loop, volume is involved. That means we have to consider a 3D body, homogeneous 3D body, and since sigma is also involved, that means R and L involved. Now R and L both are included in a cylinder. So we assume the body as a homogeneous cylinder. So whose volume is V is this. R is the radius of the cylinder and L is the length of the cylinder. Okay, so we imagine the body to be a homogeneous cylinder. That is the body is a homogeneous cylinder. So if we differentiate this, so what we get? Pi r square dl plus this 2r dr. Okay, now what will be my dv by v? by dv by v will be this pi r square dl by pi r square l plus 2 pi l r dr by pi r square l. So from which we can write dl by l plus 2 dr by r. Okay, just give it a name, say 1. Okay, just give it a name, say equation 1. Now, what is the definition of Poisson's ratio? We all know that Poisson's ratio means lateral strain by longitudinal strain. So what is lateral strain? dr by r. And what is longitudinal strain? dl by l. Okay, and if we increase in one, the another decreases, that's we put a minus sign. Okay, this is the term lateral strain and this is longitudinal strain. Okay, so from which we can write dr upon r is equals to minus sigma dl by l. So if we substitute this value of dr by r, so we get 2 sigma dl by l. So if we take dl by l common, it will be 1 minus 2. Okay, so this is the required result. Just we have to do simple substitutions. That is, we have to substitute the value of dr by r in terms of dl by l, and we will arrive at the result. Okay, so this is the second numerical. Now the third numerical, previously we have shown that shearing strain, that is theta equals to 2, and how this comes. Okay, that is a shear is equivalent to a compression and an equal extension at right angles to each other. How it will come? We just take a 2D view of a cube, say, okay, or a square. That is, we take a square, that is the 2D view of a cube. Okay, see, this is A, B, C, D. Now, what we saw, that by keeping the lower plane fixed, if we apply a shearing stress to the upper plane, then the position points will shift. A and B becomes A dash and B dash. Okay, A and B becomes A dash and B dash. That is, by keeping the lower plane fixed, if we apply a shearing stress to the upper face, then points A and B will shift to A dash and B dash. That means now ABCD becomes A dash B dash CD. Okay, so obviously this is the shearing strain theta. Okay, now if we take, suppose sides are of length, say L, each side is of length L, that is the square. Okay, now this is one diagonal and this is the original diagonals, and if we draw the diagonals of this, that is A dash B dash CD, then it becomes this. Okay, now here clearly we can see that all the line CB dash is elongated. Okay, CB, the original length is CB and CB dash is elongated, and in this side the original line is DA and the deformed line is DA dash. That means the line parallel to CB are elongated and the line parallel to DA are contracted. Okay, so line parallel to CB are elongated and that along DA are contracted. Okay, so if the sides are of length L, then what is CB? That is the diagonal CB equals to DA, is equals to L root 2. Okay, now we draw perpendicular this and this, just take this, we draw perpendicular BE and say A dash F on E and F. Okay, just take these sides. Okay, so if we take this triangle, that is B dash B, then from which we can get theta, this equals to perpendicular by base, that means BB dash by BD, theta BB dash by BD. Okay, and BD is simply L, so from which we can get BB dash this equals to L theta. Okay, BB dash this equals to L theta. BB dash we will get L theta. Now we draw perpendicular. Okay, B is perpendicular to E. BE is perpendicular to E. That means this angle is 90 degree and this is a right angle triangle. That means angle B and B dash both are 45 degree. Okay, that means angle BE dash, this is 90 degree, and since this is a right angle triangle, angle B dash and angle B both are 45 degree, no doubt. Okay, so if we take this small triangle BB dash E, BB dash E, we have just find out this angle, cosine of this angle. Cosine angle B dash means B dash E by BB dash. Okay, this angle is 45 and the cos of this angle means B dash E by BB dash. So B dash is 45, that means 1 by root 2. Okay, this is B dash E and BB dash we previously found L theta. So what we get, that is B dash E, that is simply L theta by root 2. Okay, B dash E, that is the extension. We have to find out the extension, that's why we calculated B dash E. Okay, now what will be the extensional strain, that we all know, increasing length by original length. What this amount of length is increased, that means B dash E, and what is the original length, CE. Okay, now since the shear is very small, this CE and CE is almost equal. Since the shear is small, CB and CE are equal, so we can write CB instead of CE. So what is B dash E, we find L theta by root 2, and what is CB, that is L root 2. L cancels, theta by 2. Okay, so if we take this triangle, that is along the left side, similarly we can prove from this triangle the same relation. If we take the compression, similarly we can prove E equals to theta by 2. Here we work out the example of this side. So if we do in case of that side, we will similarly prove this relation. So from which we can easily conclude that equal amount of elongation and contraction takes place at right angles to each other. Okay, so this is a simple geometrical calculation. So dear guys, in today's lecture this is up to. In my next class I will discuss about the torsion of a cylinder. Okay, so if you don't subscribe my channel, then kindly subscribe it, and if you face any problem, then just write it in comment section. Okay, thank you.